Welcome to Networks Professionals.
All right, let's dive right into this explainer and unpack the literal engine behind how neural networks actually learn. You know, it's so incredibly easy to get lost in the hype and all the technical jargon when we're talking about AI, but today we're going right under the hood. We're going to look directly at the underlying mechanics and break down what seems like unimaginably complex math into everyday, highly relatable actions. Because honestly, when you strip away the mystery, the way an AI learns, even massive models with over 1 trillion connections, is remarkably logical. And frankly, it's absolutely fascinating. So, how do neural networks actually learn? It's kind of the ultimate question, right? And it's one of the most fundamental things you can ask in today's tech landscape. To answer it, we're going to explore a continuous 4-step cycle outlined in our source material. This is the exact, literal process that transforms a network from making wild, totally ignorant guesses into delivering those highly accurate predictions that power the technology we're using every single day.
Section 1. The AI Learning Engine.
Okay, so the absolutely crucial point to grasp here is that learning for a neural network is not just a one-and-done event. It's a continuous loop consisting of 4 very specific steps. Step 1, the forward pass. Step 2, calculating loss. Step 3, the backward pass. And finally, step 4, the update. Every single time an AI gets smarter, it's executing this exact sequence. It's just a constant repeating cycle of trying, failing, measuring, and adjusting. Section 2, making the first guess. Every learning process has to start somewhere, right? Even if that starting point is entirely laughably wrong. In the forward pass, data flows directly from the input layer of the network straight through to the output layer. The result of that flow is a prediction. But let's be super clear about what that prediction actually is in the beginning. Simply put, the network is just making a guess. It looks at the data, pushes it through its current, unrefined system, and practically takes a shot in the dark. It is literally the AI equivalent of you closing your eyes and just throwing a dart at a dartboard.
Section 3. Calculating the loss.
Well, to fix a mistake, you have to actually measure it first. Here, we're comparing the network's initial prediction directly against the actual target. Out in the field, this actual target is known as the ground truth. The ground truth is reality. It's the absolute correct answer. So the network puts its blind guess right next to the absolute truth and just stares at the difference between the two. Now, to measure that gap precisely, the network calculates what's called the loss. And it does this using a mathematical method appropriately named a loss function. The entire job of this loss function is to see exactly how far off that initial guess was from the ground truth. If the guess was completely terrible, the loss is high. If the guess was surprisingly close, the loss is low. It's essentially a harsh but completely necessary reality check for the AI. Section 4, the magic backwards math. Our source material uses a really specific phrase regarding the backward pass, or as it's often called, backprop. It literally calls this the magic part. And honestly, it truly feels like magic, because this is the exact moment the network shifts from just making random errors to actually understanding why it made those errors. So during the backward pass, the algorithm literally reverses direction. Instead of flowing from input to output like it did when making its guess, it now works backward from the output layer all the way back to the input layer. It's basically tracing its own steps in reverse, like walking backward through a maze to see exactly where it took a wrong turn. The magic here is actually just calculus, specifically a principle called the chain rule. Now, don't let the word calculus scare you off. What it's doing is incredibly practical. As it moves backward, it uses the chain rule to calculate how much each individual weight, each tiny connection inside the network, contributed to the total error. It essentially points the finger, kind of like a manager trying to figure out exactly who messed up the spreadsheet. It looks at the massive error calculated by the loss function and says, okay, connection A, you were 10% responsible for this failure. Connection B, you were 50% responsible. It figures out exactly who's to blame for the bad guess. Section 5. Playing hot or cold. All right, the blame has been assigned and now it's time to adapt. During the update, once those error contributions, which we call gradients by the way, are known, an optimization algorithm steps in. A really common one is called gradient descent. This algorithm takes those guilty weights and nudges them in the opposite direction of the error. So if a weight caused the guess to be too high, the algorithm nudges it lower. If it caused the guess to be too low, it nudges it higher. It's just making these minute, highly calculated adjustments to the internal machinery to make absolutely sure the next guess is just a little bit more accurate.
Think of it exactly like the childhood game of hot or cold. We've all played it, right? You take a step and someone yells colder, so you immediately turn around and step the other way until they yell warmer. The neural network is doing the exact same thing. It moves the weights toward hotter, which in this case means a lower error, based entirely on the feedback it gets from the previous round. It tries, gets feedback, adjusts, and tries again. It's constantly hunting for the hottest possible state where the error is practically zero.
So as we wrap up this explainer, I really want you to consider this. We have just walked through one single round of this four-step engine. One guess, one measurement of loss, one backward pass to assign blame, and one tiny update to the weights. It just slightly nudges the AI toward a better answer. But here is the question you should walk away with. What incredible, complex intelligence emerges when this relentless game of hot or cold is played at lightning speed, billions and billions of times across massive sets of data? That continuous loop is the true engine of AI, and it is literally reshaping our world as we speak. Thanks so much for joining me on this explainer, and I'll see you next time.
Thanks for watching.